back, guys. Today we are back with another problem, and today's problem is a hard problem. They are saying it's a hard problem. We have to find the smallest window in a string containing all the characters of another string. Okay, so it's like a window. Whenever the topic window comes, just remember you have to apply sliding window. Just remember you have to apply sliding window like techniques. You have to apply sliding window like techniques. Okay, and what else it is saying? It is also saying that we have to find the smallest window. So what I'll be writing here, smallest, we have to find the smallest window. Okay, what next? In the string S consisting of all the characters including duplicates of the string P. Okay, so there will be two strings, S and P. Okay, we have to find the smallest window in the string S consisting of all the characters of the string P. That means suppose this is string S, okay, and this is string P. So P is completely inside S. That means all the characters are present in the string S. Okay. Return -1 if there is no such window. In case there are multiple such windows of same length, return the one with the least starting index. So in case of multiple windows, return with least starting index. So what I'll be returning is returning least starting index. Okay, so let us check an example after this. So what you can see is time to practice. Okay, so let us take one string str1 as time to practice. We are taking one str1 as time to practice. We are taking another string 2 as toc. Okay, toc. Now how can you get toc? So toc, this entire string should be present over here. So what is the starting position of this? It is a T and it ends with a C. So anything which starts with T and it ends with C. So you can see it starts with T over here at 1st position, okay, and it ends with a C over here as well. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, again it has a T at 11th position. So position number of this T is at 11. Then we have 12, 13. So if this is 13, okay, and yeah, so what are the possibilities? So either what I can see is TOC has to be present. That means there has to be another T as well. So if this is 1, 2, 3, 4, 5, there is another T which is 5, and O is present at the letter 6. Okay, so if I am checking all the possible combinations, okay, so what I'll be writing, all possible ways. So in case of all possible ways, first let me write the starting index of the T's. Okay, of the T's. So TOC can be formed. Can I form a TOC using this one where T? So let me just write the starting index of T. Okay, so if this is my T, okay, what are the possible starting index? First is 1. Okay, it has a 1 starting index. Next T appears over here at 5. Okay, next T appears at 5. What else do we have? We have another T at 11. Okay, what else do we have? So we have T anywhere else? No, we don't have T anywhere else. Let us check the starting index of O. So the starting index of O is at the 6th position. Okay, let us check the starting index of C. So if we check a C starting index, the possibility of having a C is at 2 positions, which is 10. Okay, and we also have a possibility of having a C at the 13th position. So what I have to return is we have to return in these multiple windows, return the one with the least starting index. So if I start from 1, if the starting index is over here, okay, and I want to have TOC, the string TOC present. So the string TOC can be also like this. The least starting index is toprac. Okay, now why I will explain you why we are using toprac. Okay, first of all I am going to check whether T is present in this particular point. So it is present. So I'll write a match. Okay, T is present. What else is next word? Next word is O. So is O present? No. Again O is present. So over here after 1 the O is present at 6th position, and after that over here there will be values as well. After that, when is the next When is the next value of value we have to check? C. So C is the first encounter of C is at 10th position. So C is at 10th position. So in this case, you can see the length of the string is pretty long. The length of the string is pretty long. So we are not going to take. Let us take another example where T appears next. So in this case, if I check, the T appears at top rack position, which is T. Over here, it appears at the 5th position. Okay. What the next value? O. O will be written like this. O appearing at the 6th position. After that, when does C appear? C appears at the 10th position. That means after that 6, 7, 8, 9 and C. Okay, at the 10th position. In between, you have to put the characters. The characters will be P, R, A. Okay, and so you can see the answer is top rack. The answer is top rack, as this top rack is the smallest possible substring in which top can be found. So this top letter string is already found in many possible substrings. As I told you, in this first case, the length of the substring is larger. So this is not the ideal case. So we have to see the case where the length of the string is minimum. Okay, so that is the condition of top rack over here. Okay, now let us try to analyze how we can solve this. How we can solve this with the help of a hash map, a character hash map, and that is the algorithm for it. Okay, so that is the algorithm for it. Okay, so first let us take the two strings. Okay, first let us take the two strings, and we will have a character hash map. Okay, so I'll just draw one box like that. Okay, and yeah, so yeah, so what are the value it will take? It will store the character and their frequencies. It will store the character and the frequencies. So first let me take an example of a string 1. Okay, what the string 1 contains? String 1 contains of DD, okay, triple A, okay, double B, CA. Okay, another string, we will have another string 2. We will have another string 2. Okay, string 2 will consist of A, B and C. String 2 will consist of A, B and C. Okay, now we have to check where we can find this ABC and how we can find this ABC. First, what we have to write is this particular string. Okay, this particular string over here, and their frequencies and the possibilities. Okay, so first is A. Okay, first I'll put the characters of the string 2 in my character frequency hash map. So I'll put A over here. Okay, after that what we have is a B over there. After that what we have is a C. Okay, after that what we have is a C. Initially what I can see is each of them has a frequency of 1. Okay, each of them has a frequency of 1. So what I'll be writing is this has one frequency, this has one frequency, and this has also one frequency. After that, now let's come to the position which elements which are not there, which are not initially there in string 2. So D and D is there. That means what I'll be checking is, okay, so I have D over here which is not present, so I will write -1. Whenever something is not present, let me just tell you, -1 means not present. -1 means not present. 1 means present. Okay, 1 means present. Is D present in the string 2? No, D is not present. That's the reason we are putting -1 over here. Okay, after that what we have, any other elements do we have? No, we don't have any other elements. Now let us keep iterating. First we have a D. Okay, first we have a D. So whenever we are encountering D once, okay, whenever we are encountering D once, we are putting -1. Now again D is encountered. Whenever we are encountering again, we have to decrease the count. So I have to put -2, as -1, it will become -2. Okay. Now let us check A. A is already 1. Okay, satisfied. Again A is appearing. So I'll make it 0. Okay, I'll make it 0. Okay, I'll make it 0. After that, what I'll be checking is again A is there. Again another A is coming. So in this case, I'll be making it -1. So there are total 3 A's done. After that we have a B. Okay, B is already 1. After that another B. So this B becomes 0. After that this B becomes 0. So in this case there are 2 B's. So B was already there. That means this also becomes, what will it become? This will also become -1. Okay, we have a C. C is occurring for the only one time. Okay, so that's why we are going to make it as -1. So this will become 0. Whenever we are encountering something, we are making it 0. Similarly, in this case of A, we are getting another A at the end. So this will become -2. Okay. Now, whenever I am encountering something, I will having a count variable. I'll be having a count variable. Initially, my count will be 0. whenever I'm encountering, see the count of 1, see for ABC the count of 1. So whenever I'm encountering the count of 1, what I can see is, okay, I have 1. That means I have repeated values as 1. That means I'll make it as 1. Again, you can see in the case of B. In the case of B is again a repeating. So I'll make it as 2. Again, in the case of C is being counted, means matched. So this will become 3. And my total count will be 3. This 3 is nothing but the length of this particular string. If the length of this particular string and the count matches, then only we can confirm that yes, we can get the minimum character present in that particular hash. Okay. So how we are going to solve this? How we are going to solve this? So we will be having two approaches. We'll be having two approaches. Okay. First, let us discuss approach number 1. Okay. First, let us discuss approach number 1. Okay. So how we are going to do this? So initially, we will have a minimum length. So we'll store a minimum length. I can say minimum length as 10e9. 10e9. We're storing a large length in our length so that we can relate it with. Okay. Now we will have a starting index. So I can write start index equals to -1. Okay. This is my start index. Now what I'll be running is I'll be running a loop. So what I can easily see is my loop will run from I equals to 0 till n value. Okay. And I'll be taking hash value because I don't know what characters will be present. So I will be automatically the size of the hash table should be 256 because that is the all characters. Okay. So I can write hash of 256. Okay. 256 like this. Okay. And we'll be also storing a counter. So I can write C equals to 0 over here. Okay. After that, I'll be having another nested loop J equals to 0 till M. Now you are confused that what is N and M. So if I have string 1 and string 2, this dot length is equals to N and string 2 dot length will be nothing but my N. So I have now the strings. I have now the availability of both the strings. I have the availability of both the strings. Now what next? So once I've done with the nested loop, what I'll be checking if the hash of the string of J is greater than 0, means the counter plus plus. Okay, I can write counter plus plus, or else I'll move the pointer. So initially my string, say for example in the case of this particular string, if I is there, J is there, so we have to move it. So that's the reason we have to move the pointers. So what I'll be writing is hash of S of J minus. Okay. Now as I already told, we have to check this count is equals to the length, which is I have overchecked. The count is coming 3 and the length of this particular string is 3. So that means it's a match. So in that case, I'm going to move the counter. So in that case, I'm going to move J minus I plus 1 lesser than minimum length. And what I can write is minimum length equals to J minus I plus 1, and my starting index will become I. Okay, and I can break the condition. Lastly, when I have to return, what I'll be returning is S dot substring of minimum length. Okay, substring of minimum length. So this is the total problem statement. This will have a time complexity. Of O(n) square, but we can further reduce it down to O of n. Okay, that we can discuss with the help of the code. Okay, so this is the code over here. We are seeing the code. So let us just go and check the code over here. Okay. So what we have first made a class solution. We are checking if the length of this first string is lesser than the second string. Then in that case we are going to pass a -1. After that, we are having a frequency map, which will store the frequency of all the characters. As I already told, we have to take a minimum length as large value. So we can write 10e9 or we can use integer.max value. Then we have a starting index. Then we have a hash map, which will store the window frequency. Then we are going to use the sliding window technique, where we are going to check whether the character present and the value matches. The int value means the ASCII value matches to the character at the target. If both the conditions are fulfilled, then I have used the minimum size and we can use the update function over here. Lastly, we can also check that the starting character is also the starting character present at the first string. then we can put it into the hash map. So it's all about hash map, and when the keys and the pairs and the values are matched, then we can increment the start counter. Lastly, we're going to return the minimum length as -1 if it is 10 to the power of 9, or else we are going to return the substring minimum start plus minus of minimum length. Okay, so this was the problem statement. I hope you guys could understand the problem statement. Make sure you guys share and subscribe to the channel. Thank you.